All right, so we're going to start out section 1.1. Lots of different topics in this section, but the first thing we're going to look at is the names of different number systems that we'll refer to throughout the year. A lot of the things we're going to look at in this section, if this was like Algebra 1, I'd probably do like a separate day on lots of these topics, but I don't think there'll be anything new you haven't seen before, except maybe the graphic calculator and how to zoom in and out. I think that's the only new thing. So I'm not going to formally write down a lot of definitions for these, but I will explain each one to you. So we're going to start with the innermost box, which are the simplest kinds of numbers, and then work our way out. So simplest numbers are counting numbers. And when you count, you start with what number? 1. And the next number would be? 2. There's nothing between 1 and 2. So counting numbers don't include fractions. They don't include decimals. They don't even include 0. Because when you're counting, you don't start with 0. So they start at 0 and they go up. No fractions, no decimals. Now, let's look at an example. Jaden, can you give me a counting number?
1.
1? All right. 1. And Alex, can you give me another counting number?
2.
2? All right. And if we add them together, does that give me another counting number? Yeah, that's fine. How about if we were to multiply them together? 1 times 2. Is that a counting number? Okay. How about 1 divided by 2? No, that's not a counting number. We'll talk about that one a lot later. How about even 1 minus 2? Is that a counting number? No. So if all we stick with is counting numbers, we're going to run into certain problems when we start to do other things in math. So we could even do something like this with counting numbers. So what we do at each step, we invent basically a number or a symbol that we need to do the calculation. So to do this, we invent the idea of 0. Okay? Counting numbers don't have a 0, but we need it to do certain subtraction problems. So that's where whole numbers come in. So whole numbers include everything that counting numbers do, plus they include the number 0. That's the only difference. But including just the number 0 still doesn't help us with a problem like that. 1 is a whole number. It's also a counting number, but it's a whole number. If you're a counting number, you're automatically everything else. That's the way the diagram works. So 1 is a whole number, 2 is a whole number. But is the answer you get when you do 1 minus 2, is that a number that's 0 or higher? Well, that's all whole numbers are, 0 and higher. So maybe if you showed that to somebody in like first grade, they'd say, you can't do that. When you do subtraction, the bigger number always has to come first. You can't take away more than you have. Well, you can. And that's where we invent integers. So integers now include negative numbers. Okay, a type of number that we use when you sometimes do subtraction. But it can happen in other places too. So integers include negatives, 0, and positives. But integers still don't include fractions and decimals. So let's pick an integer, negative 3. And let's pick another integer, positive 5. If I add those together, what's negative 3 plus 5? 2. Is 2 an integer? Yeah, 2 is an integer. How about if I subtract them? What's negative 3 minus 5? Negative 8. Is that an integer? Yeah, so that's fine. How about if I multiply them? Negative 3 times 5. What do we get? Negative 15. Is that an integer?
Yes.
Yeah. So those all were okay, but now let's look at division. Negative 3 divided by 5. Is that an integer? No. So if all you stick with is integers, then you can never deal with parts or pieces of something. So that's like me saying, here's 3 objects. I want to divide them between 5 people. Well, I can't. I can't take 3 objects and divide them to 5 people unless I start breaking them into pieces and I give everybody equal parts. So that's where rational numbers come in. So rational numbers include everything that integers do plus fractions and decimals. So integers are positives, negatives, zeros, fractions, and decimals. And those are the numbers that you use in pretty much everyday life, rationals. When you buy something in a store, it might cost $10.32. That 32 is 32 hundredths of the next dollar. It's a fractional amount. So basically, rational is anything you can write as a fraction. So irrational are things you cannot write as fractions. Can anyone think of a number that cannot be written as a fraction? Yeah?
Pi.
Pi. So that's an irrational number. Other types of numbers are square roots, as long as it's not a perfect square. By perfect square, I mean like 4, 9, 16, 25. If you take the square root of those numbers, it comes out nice. But anything that's not a perfect square, you can't write as a fraction. If you put in the square root of 2 on a calculator, you'll get that decimal. There's no way to convert that to a fraction. Even if you knew more decimals, even if you knew millions of more decimals, you could never write square root of 2 as a fraction. It's impossible. You can actually prove it's impossible. And then if you put together all the numbers that you can write as fractions, the rationals, and all the numbers that you can't write as fractions, the irrationals, those are called real numbers. So real numbers make up everything you study in Algebra 1. Now there are numbers beyond real numbers. Those are called, do you know what those are?
Imaginary numbers?
Yep, we talk about imaginary numbers, complex numbers, but for now we're going to stick with real numbers. So we'll talk about imaginaries later on. Some of these number sets that we talk about have symbols to represent them. When we talk about the set of integers, a lot of times they'll represent that with a Z, but they put that like extra line kind of in the middle. These symbols all have like an extra line in them. They talk about rational numbers. The symbol you might see in the book sometime is Q. Can anyone think of a word having to do with, remember, rational numbers are fractions? Anybody think of a word having to do with a fraction that begins with a Q? And maybe that's where the symbol comes from?
Quarter.
What is it?
Quarter.
So yeah, 1/4 is a fraction. That is a quarter. So good guess. Not what I was thinking, but it could have to do with that. Like, yeah.
Is it a quotient?
Yeah, I was thinking quotient, because when you divide two things, you get a quotient, and that's what rational numbers are. They're fractions. So fractions are division, and you get quotients. And then real numbers, that symbol they use is R. Now, sometimes you might see one of those symbols, you might see something like this. Do you want to guess what that would mean if I put a plus symbol on that Z? I'm not just talking about integers now, a little more specific. Yep.
I was going to think like positive.
Positive integers. Yep. And if you can put that symbol, then you can also put this symbol, and that symbol would mean negative integers. That's the only way you can see those symbols modified, though. Any question on those symbols? Yeah.
So can they all have that symbol, or is it just integers?
They all could. So like if you did this, now you're talking about positive real numbers versus all real numbers. Yep. Okay. So let's look at a few properties. You might have seen some of these before, like commutative, associative, distributive, things like that. To write down these properties, I need to use some letters. And the letters I'm going to use could represent any real number. So these properties apply to positives, negatives, zero, fractions, or decimals. Okay, so let's do it like this. Here's our first one, commutative. Does anyone remember, if you're talking about addition, what's the commutative property? Does anyone remember what it is, or I think they could give like an example? Yeah, how about Alex?
Maybe that you can flip it no matter like what way you like put it in, it's still gonna equal the same.
Yep, so you could flip it. Can you give me an example with numbers?
Like how 4 plus 1 is equal to 1 plus 4.
Yep, exactly. So you can switch the order that you add two things up in, and you get the same answer. Does that work for multiplication? Can you switch the order you multiply two things and get the same answer?
Yes.
Yeah. 5 times 2, 2 times 5. How about subtract?
No.
No. How about divide?
No.
No. So you can't apply the commutative property to subtraction or division, only multiplication and addition. We're just going to focus on addition. The next one is associative property. Okay, some people don't remember this one as well. Does anyone remember what associative means? If you're not sure, think about the first part of that word. It almost sounds like associate, associative. When you think of the word associate, would you associate alone, or would you associate in a group? A group. So associative has to do with grouping. And there's a symbol we use in math when we want to group things. Parentheses. Yeah. Sometimes you use brackets. But what associative has to do with is how you group things together. The order is the same on each side. But what we're doing first is B plus C on the left, and on the right it's A plus B. Now think about that for multiplication. If I do it on the left like that, or on the right like that, will I get the same thing with multiplication?
Yes.
Yes.
Yeah. This is 6 times 4. This is 2 times 12. Both of them are 24. So the associative property does apply, like commutative, to addition and multiplication, not to division and subtraction. The identity property. The identity is something you can do, and we're focusing on addition, that doesn't change what you have. What can you do with addition that wouldn't change the value of something?
Add 0.
You could add 0. Yep. In other words, it gives you back what you started with. Now, is there something you could do with multiplication that would give you back what you started with? It's not times 0.
Times by 1.
You could do times 1. So for multiplication, it's a little different, but there's still something you could do to get back what you started with. And that's the identity property. Okay, and the last property, distributive. Whenever you have distributive property, does anyone remember the symbol you usually see in the problem? You're usually going to see parentheses, and you're going to see something in front. Inside the parentheses, you could have 2 or more terms, and they have to have plus signs, or it could be a minus sign. I'm just showing it to you with a plus. And the idea with distributive property is you're multiplying out A times B, and then A times C. Now, I kind of went through this with you as we explained the properties, but a lot of these properties also apply to multiplication. Okay. Now, if you look at something just like that, or you look at just that, or just that, and you don't include the equal sign, those are just called expressions. Okay? So like this here, that's not an equation. It's just an expression. 2 times 3 times 4. What does it have to have in it to make it an equation? It's got to have an equal sign. So to make something an equation, you have an equal sign, and then you have something on the left and something on the right. These are all different examples of equations. Actually, 3 different types of equations right here. Let's start looking at the one in the upper right. 5 equals 2. Any thoughts about that one? 5 equals 2. Yeah.
That's not true.
It's not true. How would you get an equation like that? Well, maybe you'd have something like this in algebra 1. And I might say solve the equation. So the first step somebody would probably do is subtract 3x from both sides, and then you get 5 equals 2. That's a special situation, and it's not true. That's called a contradiction. A contradiction is an equation that is not true, and there is no way to ever make it true.
Have a good day, Mr. Hager.
Yep, you too. How about this one in the lower left? 3 plus 4 equals 2 plus 5.
It's true.
That's true. You could end up with something like that, very similar to this other one. Except when all your variables cancel, you end up with the same number on both sides. That kind of equation is called an identity. An identity is a type of equation that is always true. So we got always true, we got never true. How about 2x equals 12? Is that true or is that false? Yeah?
It can be true.
It can be true. So there's a condition to make it true, and the condition here would be to let x equal 6. So we call this a conditional equation. But they're all equations. They all have equal signs, and they all have something on the left and something on the right. Sometimes what's on one side is an algebraic expression because it has a letter. Sometimes it's just a numeric expression as it does not have a letter. I think that was it for this one. Yep, that's it. Any questions on that? All right, so let's look at an example. Actually, yeah, let's do it this way. I've got 3 properties listed here that are going to help you to change this to look exactly like that. And I'll write down the work, and then you tell me the property that lets me do what I did. Okay, so here's my first step. What property did I just use to get from here to here? Yeah, distributive property. Yep, that's the distributive property. So there's 2 ways I could have done this problem. I can either give you the work, and then you tell me the name of the property, or, let's do this one this way, I'll give you the name of the property, which this one isn't really a property, it's just kind of simplifying something that's there. And then we'll write down the work. What's in that distributive property step that I can simplify? Yeah.
2 times 3.
2 times 3. So it's 2x plus 6 equals 6 plus 2x. Now the left side and the right side are not exactly the same. They have to look exactly the same. There's something I could do to the left side to make it look like the right, and it's a property I just talked about. Yep.
The commutative property?
Yes, the commutative property. That allows me to switch the order, and it's addition, so I can do it. And then what's on the left will look exactly like what's on the right. So any questions on that one? That's kind of the first part of the lesson today. Okay, just going over the number sets and then different properties of addition. So the next part, we're going to talk about coordinate systems. First, we're going to start with 1D, and we'll do a bunch of stuff with that. And then we'll get into 2D, and we'll do some stuff with that. Okay, so coordinate system. A lot of times when it's one-dimensional, we just call it a number. Which way do positive numbers go on a number line? To the right. And then negatives go
To the left.
to the left. And then right in the middle, you got 0, which is neither positive or negative. And what do you call 0? A lot of times we call it this more in 2D, but you can call it this in 1D as well.
The origin.
It's called the origin. Yep. Now, once you create a number line, what a number line does is it gives an order to numbers. So that, like, I could take -2, and I could say that it is to the left of +3. Now, if a number is to the left, it means something about that number. What does it mean if this number is to the left of that number?
Less.
It means it's less than. And that's one of 4 different symbols we can use when we talk about the placement of numbers relative to each other. Less than is one of them. Does anybody know another symbol? These are called inequality symbols. Yeah?
Greater than.
Okay, greater than. I think that one's a little further down. So I'm going to hold off on that one. But yes, greater than. Another one?
Less than or equal to.
Less than or equal to. We just said greater than. And there's one more inequality symbol. Brady?
Greater than or equal to?
Greater than or equal to. And those are called inequality symbols. What we're going to do is we're going to look at maybe graphing something like this. I might not do that exact problem, but I'm going to look at how do we graph an inequality on a number line. We're going to do it by hand. On the test, it would be on Edge Elastic. You'll be able to click and do it that way. So there's 2 steps to graphing an inequality. First thing is we have to put a symbol on the number that's in the problem. The symbol can be one of 2 symbols, either an open or a closed circle. And the way you know which one to use, if your original problem has a greater than or a less than, it's an open circle. If it has the line under it, that means equal to, you have to fill in the circle. Once we draw a circle, then we have to do one more thing on the number line. Does anyone remember what the last step is after you draw a circle? Yeah?
You'd like to make like an arrow?
Yeah, you gotta make, a lot of times it's an arrow going one way or the other. Which way depends on what symbol you use. All right, let's try an example. So let's look at that one. They could give you a problem like that. I don't like when it's written that way, though. What do you think I don't really like about that?
Because the X is on the second side.
Yeah, the X is on the right side. I generally like to put the X on the left side. I put the number on the right side, and that's fine. You can do that. But if you want to put the letter on the left and switch the number to the right, you've got to make sure that whichever way it was pointing, think of it like this, whichever way it was pointing originally, it still has to be pointing at that number. So I think of this as like an arrow. To me, it looks like it's pointing, the arrow's pointing at the 2. So when I rewrite it, it still has to point towards the 2. And does anyone know why I like to write it this way? Because now this symbol tells me something.
X is greater than 2. Greater than or equal.
Greater than or equal to 2. But it also tells me something else. Yeah?
The way the direction you put your arrow on the number line.
It tells me which way I'm going to put my arrow now. If I keep it the way they gave it to me originally, with the letter on the wrong side, then it tells me the wrong way to shape my arrow. This is telling me it's pointing, again, think of that like an arrow. It's pointing to the right. That's exactly how I'm going to draw my arrow, pointing to the right. Let's try it. On Edge Elastic, you'd already have a number line set up. You'll just have to make one on your paper. And the first step is to decide what kind of circle we need. So Christian, what kind of circle do I need?
Filled in circle.
Yep, filled in circle. So we got that. And now we have to shade. When you do it on Edge Elastic, it's going to do it right on the number line. It's not good. Some people do it above it, and it's just going to do it right on it. So which way am I going to put my arrow? Yeah, break it.
Perhaps the right.
Yep, shade it to the right. So I'm going to do it just like that. That's it. That's x is greater than or equal to 2.
Yeah, I go did you go on?
Yep, just sign out for me. All right, let's try this one. All right, and let's say they gave it to you that way. First, could anyone tell me how I fix it so it's written the way we like it with the letter on the left? Yeah, Isaiah?
Y is less than 3.
Yep, y is less than 3. Okay, this time I'm going to number my number line by 3s. So we'll go -3, 0, 3. Okay, and Lily Rose, what kind of circle am I going to use on 3? Open or closed? Oh, yep, perfect. Open circle. And Lance, which way am I going to shade from that open circle?
You're going to shade to the left.
Yep, we're going to shade to the left. Perfect. Yep, that's how you do that. Any questions on those two? Now, there is another symbol that you can use besides the closed circle and the open circle. I'm going to show you that. So this is the same problem we just did. But in our book, what you're going to see in place of a closed circle is a bracket. Okay, you'll see a bracket. It means the same thing as the closed circle. So closed circle means equal to. When you fill in the circle, you can equal the value. When you don't fill it in, you can't equal it. Well, same idea here. If I wanted to represent all numbers greater than or equal to 2, and I want to do it the way the book's going to do it, I would use a bracket in place of a filled-in circle. The bracket has to face the way you're going to shade. In the last problem, well, this problem we did, we shaded to the right. That means I'm going to use that bracket. So put the bracket on the number, and then shade to the right. You don't have to graph it like that when you do it by hand. The only reason you may have to know that is I could give you this picture on the test and just ask you, what does that picture mean? And you would write down, x is greater than or equal to 2. Any question on using the bracket? Another place you might see the bracket is, let's say I said to you, I want you to pick a number between 1 and 10. And you can include the number 1, and you can include the number 10. One way I can write it is like this. That's the lowest number I said you could pick. That's the highest number I said you could pick. And you are allowed to pick the 1 so you can equal it, and you can equal the 10. That's what the bracket means. You can equal that value, just like a filled-in circle means the same thing. So we'll talk more about that later on, but that is one other place you're going to see brackets used a lot. Yep. Yep, just saying. Now, how about less than symbol? It's an open circle, but does anyone have a guess what symbol the book is going to use in place of the open circle? Yeah, it uses parentheses. Now, parentheses means you cannot equal the value. You have to be greater than the value, or less than the value, but not equal. So, page on the line. Same deal. You've got to put the parenthesis that's going to face the way you're going to shade. Which way did we shade in this one? Yeah.
Towards the left.
Towards the left. That's that simple. So parenthesis facing left. And draw your arrow. Just like that. Now, likewise, kind of going back to that, picking a number between 1 and 10. If I said to you, pick a number between 1 and 10, but you can't pick 1 and you can't pick 10. It has to be like strictly between 1 and 10. That's the lowest value you can pick. That's the highest. But you are not allowed to equal the 1, and you are not allowed to equal the 10. That's how you could write all numbers between 1 and 10, but not including 1 and 10. And it does kind of look like a coordinate. The only way you know it's not a coordinate is from the problem. You'd have to read the problem. So sometimes when I read answers in the back of the book and I see this, I don't know exactly what they mean. I got to go look at the problem to see what I'm reading to you. Okay. Any question on that? The last type of inequality we can graph is something like this. It's called a compound inequality. It's like two inequalities put together. And there's a word that's connected with this when you read it. You say x is greater than or equal to 2, the word, and then x is less than or equal to 9. Does anybody know what word I'm thinking of? Yeah, Alex?
What?
Yeah, and. Yep, the word and. So this is called an and. It's exactly the same thing as writing that. And if you're wondering, how do you get from that to that? Well, there's part of it, the 2, the x, and it's pointing at the 2. The 2, the x, and it's pointing at the 2. There's the first part. Okay, second part is in that box. You have the x, the 9, and it's pointing at the x. The x, the 9, and it's pointing at the x. Now, let's say you had to take something like this, x is greater than or equal to 2, and less than or equal to 9, and I ask you to put it together, to combine it like this so it's shorter. The way you do it, start with the x in the middle, put the small number on the left, put the big number on the right, and everything always points to the smaller number. How do you know if it should have the equal to under it? Well, you look at the original. This has an equal to, and that has an equal to. So that has an equal to, and that has an equal to. Now, the other way you can do it is you can put the x in the middle, but you can flip everything. You can put the bigger number on the left. I don't do it this way. Put the smaller number on the right. And what symbol do you think you would put in those two spots? Greater than or equal to, yep. And if you break it apart by looking at this, and then looking at this separate, if you look at the green box and then the blue box, you'll find those two things in those two boxes right there. I guess I used a black box for the other one. That's okay. All right, is there any question on that? Now, when we graph this one, it's going to look a little different. Anybody know what's going to look different about it compared to those two? Yeah.
Isn't it actually going to have an ending to it?
It's going to have an end, yeah. It's not going to have an arrow that goes on forever. It's going to start and it's going to stop somewhere. Where does this one start?
2.
Starts at the 2. So let's go. Okay, so starts at the 2. And we can decide if we want to use the circles or the parentheses and brackets, but don't mix them. Just pick one. Let's go with that. So you want to do the circles or you want to do the brackets and parentheses? Yeah.
Is the parentheses like the greater than or equal to?
So the parenthesis is the open circle.
Yeah.
Parenthesis you can use when you have open circles. Yeah. So you want to use the circles here or the brackets and parentheses?
This right.
Circles. Okay, what kind of circle are we going to put on 2? Yep. Closed circle. What kind of circle are we going to put on 9?
Closed.
Closed. It doesn't have to both be closed. This one happens to be, but it might not always be. There's my closed circle on 9. And where do I shade? In between. Everything that's greater than or equal to 2, but it also has to be less than or equal to 9. So when you have an and, you usually shade between. Just like this. And the way it works on Edge Elastic, I think there's like 4 toolboxes at the bottom, and they'll look something like this. And what you do is you pick which one you want. In this case, we want the one where it's closed circle on each end. And then you just drag it up, or you click on it, and then you can click on your number line. And you can change where it starts by dragging the 2, and you can change where it stops. But that's how it's set up on Edge Elastic. Any question on that one? Okay, another thing that we do look at is how far away a number is from 0. Does anybody remember what that's called? Absolute value, yep. So the absolute value is how far away something is from 0. And it's a distance. Anytime you measure distance, well, let me ask it this way. What kind of number would you never get when you measure a distance? You never get a negative. Okay, so we're always looking for a positive answer. So if you had the number 6, okay, on a number line, and I asked you how far away it is from 0, that's like saying what's the absolute value of 6, which is 6. Now the negative, again, that just means it's to the left of the number 0. It doesn't mean the answer is a negative. So what's the absolute value of negative 3? 3. Okay, and that's how you find how far away something is from 0. But what if you had something like 0, and then you had something here and something here, and you want to find out how far apart those two are? What operation could you use to figure out how far apart just any two numbers are. Subtraction, right? Like if this is, if you want to find out how far apart 2 is from 6, it's 6 minus 2. Right? It means they're 4 units apart. You have to subtract them. Now, can I do it this way?
No.
Not exactly like that, but there's something I could add to that then it would make it work. Yeah? I could. I can add the absolute value bars in. So whether you do it this way or that way, it doesn't make a difference. The point is, if you want to find the distance between two numbers, you subtract them and then take the absolute value. Doesn't matter what order you subtract them in because you're taking the absolute value. Okay, so we'll do example 4, and then this will finish up like the one-dimensional coordinate system, and then we'll go into two-dimensional coordinate systems, which is where we're going to try something on the calculator. Okay, so it says to find the distance between -2 and 9. Chris, what's my A in this problem that I'm going to plug into the formula up above?
-2.
Yeah, it's my -2. So we're going to plug in that for A. And how about Hunter, my B value?
That would be -9.
That's -9. So we're going to plug that in for B. So just take the numbers and fill them in. So the distance is A minus B. Okay, so let's start to simplify what's inside there. Raina, what's going to happen when I do -2 minus 9?
It's going to change to -2 plus 9.
Okay, so we're going to change it to a -2 plus 9. And how about, Owen, what's -2 plus 9?
+7.
It's going to give me +7. And the absolute value of +7 is 7. Okay, so that covers most of what I wanted to talk about with just a one-dimensional coordinate system and absolute value. Okay, two-dimensional coordinate system. Well, in 2D, now we have two number lines. But we don't just call them number lines anymore, we label them. Does anyone know what we call the horizontal number line? Yeah.
X-axis.
X-axis. And how about the vertical number line?
The y-axis.
The y-axis. When you draw an x and a y-axis, it separates the coordinate plane into 4 sections. Does anyone know the name? They're not sections, they have names. Yeah?
Quadrant.
They're quadrants. And does anybody know where quadrant 1 starts? Yeah?
Top right corner.
Top right, and it goes counterclockwise. What do you call the spot where the x and y axes cross?
Origin.
The origin. I think that's pretty much everything. We didn't say which ways were positive and negative, but like a number line, positive goes right, negative goes left. And for the vertical, positive is up, negative is down. The Roman numerals are numbering the quadrants. And if I put something on here like that, and I want you to describe where that point is, there's a name for the thing that you use to describe where that point is. Does anybody remember the thing that describes where a point goes? Yeah?
Coordinate.
Yep, a coordinate. And specifically for two-dimensional, we call it an ordered pair. If you were doing 3D, it's called an ordered triple. Still a coordinate, but it's 3 of them. When you write a coordinate, your x always comes before the y. X is horizontal movement. Y is the vertical. Now I'm going to show you how to do something on the graphing calculator. So in general, if something happens on the calculator the day of a test and it's giving you like this weird error and it's not related to anything I've taught you, I would help you fix it. But if the question was to set your calculator to a viewing rectangle and they give you dimensions, that I wouldn't help you with because that's what I'm going to show you how to do right now. All right, so first thing you want to do is go ahead and turn your calculator on. And once it's on, if you're at a screen that's not the main screen, you can press the blue button, which is second, and then you can press mode, which is quit. So anytime you press the blue button, it's going to do what's written up above in blue. Now, when you press second quit, you might be at a screen where somebody did a calculation. If you don't want to see what's on the screen, you can press clear and it'll get rid of it. Okay, is everybody at a screen that looks something like that? All right, so what we're going to do is we're going to type something in, we're going to draw a picture of it, and then we're going to graph it. So anytime you want to graph something, you have to press the button in the upper left that says y equals. When you press that, it's going to give you a list of, I think there's like maybe 8 or 9, maybe 10 different graphs you can do at the same time. If there's already one there, just press clear, and that'll get rid of it. So that's the first thing. The other thing is, if yours looks like this, and one of the plots is highlighted in black, that means it's turned on. This is a scatter plot. We're not doing any scatter plots today. So if one of these plots is highlighted in black, you have to go up to it, hit enter, and then it won't be highlighted in black anymore. So all 3 plots should be turned off. And there should be nothing in these y equals. Let me pause for a second there, but anybody need help getting their screen to look like that? Yeah. What's on your screen? Let's take a look. So you just want to clear what's there, so if you press the clear button, it'll get rid of what's there. Yep, you're all set. You're welcome. And it'll probably say test mode on the top of the calculator too. That's fine. That doesn't matter. All right, so let's type something in. I want to type in x squared, and let's do plus 12. I'm going to type in x squared plus 12. Okay, so here's how you type it in. To get the letter x, it's the button right below mode. It's to the right of alpha. And it has an x, comma t, comma theta, comma n on it. Just press that. There's a few different ways to do exponents. Since we're doing x squared, the easiest way is to press the button that's 5 down on the left. It has an x with an exponent of 2. So that's x squared. And now we want to do plus 12. So you press the plus sign on the right-hand side, and then just hit plus 12. So at this step, everybody should have something that looks like that. Does anybody not have something that looks like x squared plus 12? Okay, now once you type it in, you never want to press graph right away. The first thing you always want to do is either check your window or set your zoom. We're going to set our zoom first. So if you press the zoom button, which is the third one over from the top, there's different ways we can set the screen up. Most of the time, for now, we're going to do zoom 6. What zoom 6 does is it sets a window that goes from -10 to 10 on the x-axis and -10 to 10 on the y-axis. That's the size of the screen it'll set. So we're going to go zoom 6. You're going to see in the upper right-hand corner a little yellow circle spinning. When it's done spinning, it's done doing what it wanted to do. How many people ended up with something like that? Okay, so it looks like nothing was drawn at all. It drew something, but it's off the screen. Is that what you got?
I just drew.
And you did zoom, and you did x squared plus 12?
Yeah.
And you did zoom 6?
Yeah. I was trying to know why.
Let me see what you typed in for the y equals in the upper left. That's plus 2.
because I did +2, my fault.
Yeah.
Yeah.
So this is going to happen a lot, where we draw a picture, it's not on the screen, we have to find it. So the way we're going to find it is we're going to practice changing what's called the window, or the viewing rectangle. Yeah.
So mine shows like 2 squares on pair of 3.
2 squares. Okay, and did you turn off all your you turned off all your scatter plots at the top, plot 1, 2, and 3?
Yep.
None of them should be highlighted. No, one of them's highlighted in black.
Just
Hit enter. And now hit down. And see how it's not highlighted now? Now it won't show you those little squares. Okay, so when they ask you to set a window, they're generally going to give you 4 numbers. Those 4 numbers, if you press the window button, which is right next to y equals, are going to go in this screen. Where they go is for the x min, the x max, the y min, and the y max. I'll tell you which one is which. That is your x min. That is your x max. That one is your y min, and that one y max. So you always put the x's first, min, max, and the y's second, min, max. Now, let's start typing them in, but you got to be a little bit careful. There's a negative symbol in front of the 20. There's 2 symbols on the calculator that look like a negative. There's the one that's down below the 3, and then there's the one that's on the right-hand side. I don't know if you can see it well, but they're not the same. They're a little different. One of them is a negative symbol to put in front of a number. The other one is used for a subtraction problem. We are not doing a subtraction problem. So we're going to put in the button below the 3, which is negative, and then press 20. For x max, it says to put in positive 20. So you just type it in, and then you just hit enter. Don't worry about the XSCL. It stands for X scale. I'll tell you what that is in a minute. It's not really that important. The Y min, negative 20. Y max, positive 20. So what we've just done is we've made the window bigger. Okay, it's now going to include more. So let's hit graph now that we have those numbers in. Now you should see the U shape that we typed in originally. So it was off the screen. Now it's not. Does anybody know what that U shape is called?
Parabola.
Yep, that's a parabola. Yep. Now these, if you look, what you're seeing here, these little marks, those are called the tick marks. And if you change the scale, you can change how often you see a tick mark. Now, I never sit here and count these tick marks anyway, so it's not really important to change. But if I change it to 5, now you're seeing a tick mark every 5 instead of every 1. That's what the scale is. And that's pretty much all I'm going to show you on the calculator for today. Any question on what we just did there? Yeah?
Mine's not showing it.
It's not showing anything? Let's see, you set your window. Let me see your window, negative 20. Okay, let me see what you typed in for an equation. X squared plus 12, and then hit graph. Let's see, go back to y equals for a second. So you have y equals x squared plus 12. Let me see. I'm just going to type it in again and see if x squared plus 12. Yeah, I should have checked how you had it typed in, because I just typed in x squared plus 12 and then it just showed up. So it might have been something about the way you typed it in. Did you press this button to get your x?
I think it was because my equal sign was highlighted earlier.
Oh, okay. So, yeah, see how my equal sign is highlighted in black? If you accidentally do something like this, you hit enter on the equal sign. See how it's not highlighted in black now? I just turned it off. So when I press graph, it doesn't do anything. So if you notice it's not doing anything, highlight the equal sign, hit enter. Now it's turned back on. Now you get your picture again. So yeah, that's what it was. So something like that, I would help you on a test because I hadn't shown you that if you highlight the equal sign and hit enter, it turns the graph on and off. Now I've shown you that, so I would expect you to figure that one out on your own. Okay, so any questions on that viewing rectangle? So now, what I usually do, especially if it's my calculator, so the next time I use it, it's ready to go, I just clear what I had in there. I press second, and then I press quit to bring me back to the main screen. And now, next time I turn it on, it'll be right at the main screen, ready to go. The way you turn it off, press second, and then press the on button, and that'll turn it off. Hey, you can just keep it at your desk for now. We're done using it, but you don't have to put it back right now. When you do put it back, always make sure it's off and put it back in the right spot. All right, so last thing. So when we look at a two-dimensional coordinate system, we can find the distance between 2 points, just like we did on a number line. But it's a little different. On a number line, I might just have a point here and a point here, and they're perfectly straight, horizontal, or vertical, so I can just count. Well, in 2D, we could have something like that. And I want to find that distance. Does anybody know how we do it? I'll give you a hint. We make a certain shape out of it, and then we use a certain formula. Yeah?
So it's like rise over run, so you go up 3, and then you go to the right, however many blocks there are.
So we are going to kind of figure out how high we go and how far left and right we go. We're not necessarily finding the slope, but we are going to use the numbers that would be in the slope to do what I'm thinking.
Okay.
Yeah?
Pythagorean theorem.
Yeah, we have to use the Pythagorean theorem. So the idea is you figure out how far over to go, and then you figure out how far up to go. Now those two distances should be easy to find. You can just count. 1, 2, 3. This one is 1, 2, 3, 4, 5, 6, 7, 8. Now that we know those two numbers, we can use Pythagorean theorem. Okay, so what does the formula look like? It looks like this. First of all, you'd be given two coordinates. So in my problem, you could pretend like this is P. That's Q. And there's the formula to find the distance between them. This part, right here, x1 minus x2, x's are horizontal. That gives you this. That's x1 minus x2. This part right here, y1 minus y2, y's are vertical. That gives you this part right here. Then the Pythagorean theorem, which we're not really going through any proof of that today, but the Pythagorean theorem says that if you take two sides of a triangle, you square them, you add them together, and then take the square root, it'll give you the length of the third side, which is the distance between the 2 points. And that's what we're trying to find. So if you ever forget the distance formula, but you remember the Pythagorean theorem, that's what you're really doing. Right, let's try this. So find the distance between 1, 4 and 5, 6. So first thing I do is this. Write down everything in the formula. Now all I have to do is fill it in, and I don't have to think about the formula at the same time. So write the formula. You can have a reference sheet on tests, so this would be a good formula if you want to make a reference sheet to put on your sheet. All right, and now let's plug in the numbers. What's x1 in this case?
1.
Sure, you do 1. What about x2? 5. And y1? 4. 4. And y2? 6. Okay, now we'll go through and simplify that as much as we can. 1 minus 5 gives me negative 4. It wouldn't really matter because then when you square it, you get 16. How about 4 minus 6? Negative 2. And what about when you square that? 4. And that gives you the square root of 20. Some square roots can be simplified, okay? And I don't mean you plug it into the calculator and get the decimal. I mean you just reduce it as much as you can. Does anyone know what the square root of 20 reduces to?
2 square roots of 5.
Yep, it reduces to 2 square roots of 5. Here's how you can figure that out. There's lots of ways to do it, but here's one way. Think of how you can break up the number 20 into 2 square roots. 2 numbers that multiply together to give you 20. But one of the numbers has to be something you can take the square root of in your head. So what are 2 numbers that multiply to give me 20? Yep.
5 and 4.
Yep, 5 and 4. So you can write it as 2 separate square roots. 2 and 10 would not be a good choice because neither square root of 2 or square root of 10 comes out nice. But square root of 4 and square root of 5, that's a good choice. What's the square root of 4? 2. And that's how you simplify the square root of 20. That's one way.
I found mine a different way. I did the square. I took 20 and split it into 10 and 2. I split 10 into 2 and 5. I had 2 2s. I took the 2s, put the 2 on the outside, but 5 on the inside.
Yeah, so you can make almost like a tree and kind of break it apart. That's another way to do it too. Yep. I don't care which way you do it. But really the point of this problem was it connects with XY axis stuff, which is what we're talking about, and it reviews how to simplify a square root. So that's more of an Algebra 1 thing, definitely something we can review if people have questions on, but not something I'd specifically spend like an entire half hour teaching you how to do in Algebra 3. All right, so that's distance formula. And the last one is midpoint. So midpoint, a little bit different than distance. We're not finding out how far apart two things are. We're finding where the middle is. So if I go back to my diagram of my triangle, what's in the middle? Might be right about there, between P and Q. And the formula to find what's in the middle, well, think about if you had two grades and I wanted to know the one in the middle. How do you find the middle of two numbers? Like if it was like a grade on your report card, you got 100 on a test and you got an 80 on a test, I need to find what to give you. Yeah.
I just get them divided by 2.
Yeah, what do you normally call that? You can call it the middle, but it's really, yeah, it's the what? The median?
Mean.
Oh, the mean, yeah, the mean, or the average, exactly. There's mean, median, and mode. We don't really study those, that's statistics. Sometimes they come up a little bit, but yeah, the mean. And it's exactly what Jacob said. If you take your x's and you add them up and divide by 2, take your y's, add them up and divide by 2, you're basically doing the average of the x's, and then you're doing the average of the y's. That's the midpoint formula. I don't know why it's jumping around a lot. I'm not sure why. I'm going to do the problem up here because I got a little more space. Okay, so let's find the midpoint between -5.2 and 3.7. A little different than distance formula. Some people mess this up. Plus sign. Minus. So that's why I think it's good to have a reference sheet. Make sure you don't mix those up. Okay. What's x1?
-5.
-5. And x2? 3. How about y1?
2.
And y2?
7.
7. So when we're done here, the answer is not going to be a number, it's going to be a coordinate. That's the midpoint formula. You can leave your final answer with a fraction or a decimal, unless they specifically ask you for one or the other. So what's -5 plus 3 divided by 2? -1. That's -2 divided by 2. And how about 2 plus 7 divided by 2? 4.5. Generally, we won't use a mixed number, so you could write 4.5, or you could write 9/2. Either way. And that's how you find the midpoint between 2 points. Okay. Any questions on that? So a lot of different topics in there. We normally don't cover that many topics when we get to material that's new. We'll focus more just on one thing. But I'm hoping the only new thing today maybe was zooming on a graphing calculator. Hopefully all this you've seen at some point. Okay, so that's the homework for tonight. So it's 3 through 11 odd, and then 12, 15, 20 to 22, that's all, because it doesn't say odd or even. And then 28, 31, and 44. So it might take a little bit just to get used to how the book asks questions. So a couple things I can think of is sometimes the book will refer to a graphing calculator as a grapher. So if it says use your grapher to do something, it means graphing calculator. If there are any problems that say find, or set your window to these numbers, there might not be any work to show on paper. You literally are just practicing typing in the min and max values on the calculator. So not every single question has work that you need to show, but we'll kind of figure out that stuff as we go. Is there any questions on homework for tonight? Yeah.
Where are we getting the homework from? Is it like posted online or?
So the homework, remember the textbook is online, so you can download the entire textbook by chapter, or if you go to Schoology and you go to lesson 1.1, there'll be a PDF in there that's just page 11, and it might go on to page 12. So there'll be a PDF that's just the 2 pages that you need. So you can do it either way, download the whole book, which is on there, or just page 11 and page 12, that's on there as well. Yep, but it's all on Schoology. Does everybody know where to find it on Schoology? Okay.